All right, so this is we're recording. This is another homework 9 question. This is number 6. This one's just a little tricky just because of the Rayleigh criterion, which is just like a special parameter wherein it occurs basically when 2 points are separated by the angle. So like it would be angle equals 1.22 and then lambda over d, right? Where lambda is the wavelength of light and air, and then d is the diameter of like the aperture, right? So like whatever the light's going through. So in this case, we're told it has like a diameter of, what was it? Yeah, so the diameter is 1.5 millimeters. And we're using the Rayleigh criterion. So that's basically like to start thinking about that equation when you see that. And more or less, it's saying that like the angle is super small. So just by like that small angle theorem, like we can say that, you know, tan theta. So remember this, that's that Rayleigh criterion. Essentially, we have like a triangle, right? Like how this thing is with like the 2 dots. And we have like our thing, like the aperture, the light's going through. We're going to call that distance, I'm going to call that d. And then from here to here, I'm going to call this L. And I'm going to call this Y. Right? And we're going to have like the 2 points, right? So that's kind of, I guess it'd be helpful for me to read the question too, right? So problem 6 says we have 2 dots separated by a distance of 2.5 millimeters. That's what I consider my Y. Assume the diameter of the pupil is 1.5 millimeters. That's my big D. And then the wavelength is, 400 nanometers. And then we're going to use that Rayleigh criterion to determine the maximum viewing distance from which the 2 dots can be distinguished, right? So in this situation, the angle is so small that like tan theta just equals the Y over L, right? So the opposite of theta, which is right here, opposite over adjacent, right? So Y over L. And then because of that, and then that Rayleigh criterion tells us that we can use theta equals 1.22 lambda over d, right? Lambda over d. So we can now convert that theta into what it actually, like Y over L, right? Because we discussed like small angle, super small angle. So Y over L. And what we're solving for is L, right? So we want to know the viewing distance such that the 2 dots right here and here can be distinguished. So I'm just going to flip everything. So it's going to be L equals Y big D. Sorry, my handwriting is sour. It's at the bottom. So Y big D over 1.22 lambda, right? So at this point, you know what the Y is. They gave you that. You know what big D is, and you know just the 1.22 times that 400 nanometers, right? So that's 2.5 times 10 to the minus 3. Big D is 1.5 times 10 to the minus 3. So yeah, just go plug that in, and then you'll get your L value. Yeah, that's that one. Pretty short.